I think we all enjoy a good prior repair attempt video, don't we? Let's do another. Alright, so let's get this out of the box here. This poor guy has been abused. Some broken out glass. Let's take a look there. Hello there, Mr. Rapid Man. Email's actually repair man, but close enough. Sending you my 03 Tahoe cluster I'd previously done some work on, trying to fix myself, but had failed to do so. Been watching your videos. I don't have the tools to get it done. Thanks, great videos. Below, I will give you only things that are working and things that don't work. Please also upgrade LEDs as white as you can. Okay. So the good, the backlighting and the right turn signal. The bad is no needles work. Info display doesn't work. Left turn signal doesn't work. ABS, check engine, and other lights don't work. All right. Let's switch over to the narrow lens here so you can get a zoom in. Oh boy. Let's turn off some lights here. So we have, we got a couple of flickery LEDs. Yeah. Common misconception that using LEDs gives you better reliability, but that's not always the case. Yeah, so she's dead. Just like he said, no life at all. Except for some backlighting. And that doesn't look so great either. Let's get into her. And yeah, I can tell it's a previous repair even without them telling me. First giveaway is all the fingerprints and scratches all over. Oh, and also clips on the bottom are always broken. People start at the top. You start at the top and then pull at a little bit of an angle. You don't have to break these clips off to get it apart. Got my helper over here checking out the box. Dang cats and boxes. Come on, get out, kitty. All right. I had to shoo the cat away before you got cat hair and everything. Okay, dokie. So we got one X27. Looks like the rest are original, and these are the LED. Oops, I think I just bumped. Yeah, I just bumped one off. Oops, we're throwing those away anyways. And here we have the cruise control light changed over to an LED. Not a fan. Like I said in other videos, the cruise control, which is this guy right here, it runs through a green color filter on the face. So you really, I mean, even if you do put a colored LED behind it, it's still going to come through as mostly green anyways. So that's why his left blinker's not working. It's just gone. Right blinker is looking kind of haggard. Yeah, just sloppy, the usual sloppy solder joints. Let's look at the X27. Yeah, the famous solder blobs. So how much you want to bet there's no pads under there? I see the plug has been reworked. I know there's a video on YouTube where some guy claimed his cluster didn't work. He resoldered the pins and then it worked, but to tell you the truth, 97% of the time resoldering this does not fix your solder problems. It's fractured joints on the top. The only time I've seen these actually truly fail is when the owner is doing this to the plug, trying to find out why it's not working, because if you twist the board, put pressure on the board, those fracture solder joints close, the cluster starts to work, and they think that, oh, I put pressure on this, that must be the problem because it started working, but well, in fact, it's on the front side of the board. And there's something going on here. Yeah, it looks like these three starter motors were messed with, but they're still XC5, so anyways. And up here, I don't know if my camera picks that up, but there's actually some shorts, solder blob shorting out these three caps up here. There's just some, oops, some of these solder blobs are just falling right off the board. Okay, let's get started. So in cases like this, what I usually like to do is undo everything they did, clean it all up, start from the ground up. So that's what I'm going to do. All right, so backside of the board went a little better than I thought. I was completely surprised, but the pads that were under the solder globs are perfectly fine and intact. I did notice strange corrosion mark here next to the transformer. I'm a little concerned about what might be going on here. Of course, that could affect the displays. Also a strange, something a little weird going on right there too. It's normally not there. But the back of the board is surprisingly healthy. I did notice they also reflowed these pins here for the gear select display, which is probably unnecessary. I've never seen these joints fail, and there's a little bit of rework here on this bottom VFD. The backside's good enough for now. I'm going to get up under the microscope, maybe clean up some of these solder joints right after I yank off these old LEDs. Now with all the unnecessary solder blobs removed, this is all the extra solder I pulled out of the FR300 just from this board alone. So I cleaned up all the solder joints that needed to be cleaned up, and then fixed all the solder joints that didn't need to be touched up but were. I don't even know if this thing boots up. As far as I know, the processor has been damaged by static discharge, but let's see if it even comes alive. Oh, we have something going on here. So it did boot up, but I wonder if that little corrosion looking spot on the back, on the bottom side of this power supply has something to do with that. Display not working. So it has life. That's a good sign. But I'm worried about this little corrosion spot right here. I might have to see if that's causing a short. We might have an issue in this VFD power supply somewhere. There is a missing cap. I think that's just a filter, input filter cap from probably one of the analog inputs. I don't think that would be necessary for the display to come on. I'll fix that later. The only problem left is to find out why the display is not coming up right. Alright, so I just double checked solder joints and whatnot on back. But it looks like it is definitely the power supply and not the display. There should be 42 volts sitting at this cap, and there's 5.6 volts sitting at this cap. So let's see what happens if we actually force 42 volts into that cap. Will it come alive? Will it blow smoke? All right, so we got the cluster on, 42 volts. Got my test leads now. Okay, so confirmed power supply issue, and not the display itself. Sucker's got a lot of hours, a lot of miles, 275. All right, I'm getting off topic a little bit here. We got to fix this power supply. Now, focusing back on this little section here that has me concerned, it looks like it might be some sort of a liquid damage. There are a couple of small spots there too, but there is a via coming off of this transformer, this trace here. It goes to a test point, but here's a via that on the other side of the board, it comes out of this hole and goes to the top of the diode. So this is like the main output of the transformer through the full bridge wave rectifier. I'm pretty sure that's what that's set up for. Anyways, this via is a little darker in the middle than the other. So let's see if we have continuity from the output pin of this transformer through here to the other side and the top of this diode. So let's get the meter continuity. All right, so looking back, a couple of test points we can go from, but I'm going to see if I can rest my meter lead right on that. And then on the other side, get to the top of that diode end. I don't have any beeps. Let's see if we get a beep from, just see if I can shove this in here and get to the tops. That's not a good spot to take a test point. All right, so I can confirm. So here to here is good, but when I poke the via, I'm not getting any beeps. Let me check again from this pin. I'm gonna hold that tight onto this pin, so see if I can get continuity from there. There, you hear the beep? I can get it if I touch here, right at the other side of the pin, but I'm not getting it there. I'm not getting it at the via. I think I'm just gonna go ahead and maybe it was jumper. I don't know, either clean out the via or jumper. One way or another, I gotta get power to that diode. right, and power. Yay, it works. Look at that. All right, back in business. Okay, looks like everything is working. Now I can just finish off with a normal rebuild. All right. So the left blinker is still not working. Here I thought it was just because there wasn't a bulb, but there seems to be a issue with the board. Left blinker comes in through B1. B1 is this corner pin right here, so that would be this pin right here. I'm going to take a look at this under the microscope. And I thought I was almost done, but while I was investigating on why the blinker wasn't working, I sucked up all the solder balls on the connector, and there are 1, 2, 3, 4, 5, 6, if you count this one, 6 pulled pads under the connector solder balls. So I guess I'm not quite done yet. I'll have to run some jumpers. And the unfortunate thing was, there's probably nothing wrong with this. This is one of those deals where they tried to fix something that wasn't broken and then broke it in the process of trying to fix it. So even after fixing the pulled pads on the connector, still don't have a left blinker. This is one determined left blinker to not work. But I think what we have here is another open via. So this is where the left blinker signal comes in, right at this pin in the corner here. It goes to the foil trace on the back side, which just leads to this via right here. So it's just a short little jump. But if we check the voltage from the pin to after the via, see if I can do this without shaking the camera too much and getting the meter in view. Okay. So look at there, all of our voltage is across what should be a conductor. So we have 13 volts from the pin to the via, and it should be 0 because it should be a conductor. So I'm going to try to patch up this via, and then that should finally get our left blinker to work. Alright, I ran a jumper off camera just because I'm kind of ready to have this one done. But I just ran right on the top side here from the incoming pin right up to this little filtering capacitor, which is all tied into this via and everything. So I just kind of took a shortcut, and now when I power it up, we finally have a left blinker. Alright, so I think it is now safe to start assembling and then do some further testing. Alright, if this face doesn't clean up, he's getting a replacement. Got some gooey fingerprints here. I normally don't like scrubbing this little window because of how easy it scratches, but we got to get this big thumbprint off of here, and it's not coming up. Garbage. Here's a used one in a little bit better shape. Doesn't have the previous repair temp fingerprints. Okay. Alright, now I've got the cluster fully hooked up for testing. We've got the signal generator going to confirm RPM and mile per hour are behaving. And then for the serial data, I'm going to go ahead and crank up some of these to make sure they're all responding, and yes they are. So we know the cluster is communicating. And let's go down the checklist here. So originally it had no working needles. They're all working now. Info display is back up and running. Left turn signal's good. ABS, check engine, and the other warning lights, yeah, they're all working. And it looks like that does it. Now, this is the one with the broken lens, but the owner of this cluster already has a replacement lens that they're going to put on when they get this back. This is just going to be put back on to protect the cluster in shipping. So I think this one's finally done. All right, guys. Thanks for watching another one. See you next time. If you'd like to see more broken clips, fingerprints, self-repair attempts, look at that. Subscribe for more. All right. See you next time.